I wanted to start with the idea that years ago, when I first read about the global warming issue, I mean, there were articles back in, I think, the 1830s, but it was sort of the mid 20th century that it became more of a crisis of some sort. And so, but when the original articles came out, they were kind of focused on what you're doing now on the Gulf Stream and what's going to happen when the Earth warms, the oceans warm, and the Gulf Stream changes. So I thought it would be really worthwhile to have you explain a little bit more about sort of the history of the Gulf Stream, partly where it came from. From what I'm reading, it's also one of those on or off things. If we turn it off by what we're doing, we can't turn it on again. So anyway, that's why I was hoping you could help clarify for us.
Sure. I mean, that's a big question, basically. And I guess knowledge about the Gulf Stream, now I'm talking about the Gulf Stream, and we kind of have to differ later on between the Gulf Stream and the Gulf Stream system, or AMOC, as these are not identical. That's an important fact. And I guess the importance of the Gulf Stream, the knowledge about that goes back hundreds of years, in the sense that, I mean, just about the time when you had, I don't know, a lot of ship traveling basically between the United States and Europe, people obviously noticed that it was, or you were able to go much faster from the US to Europe than the other way around, basically because you have this strong system of currents that goes along the United States coast and then deflects towards the inner Atlantic and then going towards Europe. We kind of have to differ here between, as I said, the Gulf Stream and then what we call the AMOC, the Atlantic Meridional Overturning Circulation, because just the Gulf Stream is, for example, we are not really worrying about the Gulf Stream collapsing, actually not at all, because the Gulf Stream itself is mainly wind driven. And as long as the winds don't change, it's not going to stop. And it's just going to keep flowing. And we don't think that due to climate change, there will be a major change in the wind system. So the Gulf Stream itself is safe. But what we are talking about, the AMOC, the Gulf Stream system, is a system of currents which basically governs or spans the whole Atlantic. So we have water masses starting in the Southern Ocean, the South Atlantic, which first of all flow along the coast of Africa, then cross the Atlantic about the place of the height of the equator, the latitude of the equator, and then flowing along the United States coast, going towards the inner Atlantic, and then upwards towards the subpolar or polar Atlantic. And this Gulf Stream system, I kind of differ between these two names now. So the scientific name for this system of circulations is Atlantic Meridional Overturning Circulation. And I guess it's probably maybe even the better name, because it pretty much describes very well what it is, in the sense it's a system of ocean circulations that is in the Atlantic. It has mainly a meridional, that is a north-southward or south-northward flow. And it's linked with an overturning of water masses, which means that the northward flow is actually a surface or subsurface flow from the Southern Ocean towards the North Atlantic. And then in the subpolar North Atlantic, these water masses, as they cool down or are cooled down by the atmosphere, start to sink. And we have a return flow from the north to the south at a depth of about 2 to 3 kilometers. So we have an overturning of water masses. And we call it sometimes Gulf Stream system because the Gulf Stream is kind of part of this system, in the sense that where the Gulf Stream is, we kind of have an overlap of these two current systems. But as I said, the Gulf Stream has the second part, which is wind-driven, which is not really affected by climate change. But this overturning part, which is also important, or which is really important because this is actually what is mainly responsible for the northward heat transport, which is because we have this surface flow of warm water masses and the return flow of cold water masses, and this exchange of warm and cold waters leads to a large heat transport towards the north in the Atlantic. And this is the part where we are worried about that it might collapse. And as you said, we might actually or could end off in an off state of the circulation, and it would be very, very difficult to turn it on again.
Yeah, could you explain a little bit about how this affects the climate and obviously the weather in like North America as well as large parts of Europe?
Yeah, so basically why it's so important with the climate, especially in Europe, is because, as I said, we have this large heat transport by the ocean circulation. And this heat transport is actually, it kind of depends at which latitude you look at, but it can be up to more than 1 petawatt, which is approximately the energy produced by 1 million average-sized nuclear power stations. So it's a huge amount of energy. And as the ocean or as the circulation goes northward, this warm water will be cool or will be warmer than the atmosphere above it, because we're getting into colder regions. And so just when you have a temperature difference between ocean and atmosphere, heat will be released by the ocean to the atmosphere. And this is why the effect is even larger on Europe than on the United States, is that we have prevailing westerly winds over the North Atlantic. That is, a lot of this heat is transported towards Europe and therefore has a large effect on the weather, which is even, it's actually largest in wintertime, because that's when the warming effect by the ocean basically is the largest. It is still so that it's not the only reason why basically the European climate is milder, but it's a major reason.
Yeah, excuse me, what I'd read years ago was that if the warming temperatures affect these currents, that the United States might become warmer, Europe is likely to become much colder. And it sounds like that's what the most recent studies are saying.
Not exactly. So basically what we know is that the warming effect by the Gulf Stream system is largest on Europe, but actually it affects the whole Northern Hemisphere. So there are studies that show that the AMOC is one of the reasons why the Northern Hemisphere is actually on average warmer than the Southern Hemisphere. Simply added, we have our globe, and we have basically the sun warming our globe. And on average, the sun will warm the equatorial region the most and the polar regions the least. And so we have a temperature difference. And basically both the circulation system in the atmosphere and in the ocean will work towards decreasing this temperature difference, which is caused by the sun. So basically, when you, for example, look at the atmosphere, you will always have heat transport from the equator towards the poles by the atmosphere on average. And the Gulf Stream system, the AMOC, is special because it doesn't just transport heat from the equatorial region towards the North Pole, but it can actually transport heat from the Southern Ocean, from the Southern Hemisphere towards the Northern Hemisphere. So when the AMOC stops or would stop, then we expect cooling over the whole of the Northern Hemisphere, which is just most pronounced in the European region, but it will also affect the United States in the sense that we expect, if we really have a collapse of the Gulf Stream system, we would also see some cooling in the United States.
Would it cause warming in the Southern Hemisphere?
Yes.
All right, so it's going to affect everything all over the world.
Yes.
Paris Agreement was put together with some hopes of keeping the average temperature increase of the Earth below 2% centigrade increase. We're not there yet, but you're already seeing, from what I can tell, a weakening of the AMOS. I think a lot of people thought as long as we win on the 2% goal, a 2-degree goal, that things are going to be okay. And this summer, we're finding out that things aren't okay, and we're not there yet. And this is one of the issues that I think is now, getting a little more attention. So how touchy is it, or how fragile is it in terms of temperature increases?
That's a really good question. And it's actually a frustrating question, I'd say, for us scientists, because I would say we're not really closer to answering this questions than we were like 20 years ago. So, well, you're right. And I'd say that's still the main belief, or I guess most scientists would still say that as long as we stay 2 degrees below 2 degrees of global warming, the AMOC is fairly or pretty safe in terms of not shutting down completely. We'll definitely see a weakening. So basically, if we have any time of global or any amount of global warming, this will lead to a weakening of the overturning circulation. And so for us, the important question is, okay, how much weakening is so much that the overturning circulation will, what we call tip, which basically means that just a little bit more of global warming could lead to the shutdown of the overturning circulation. And where this temperature threshold is, we don't know. And yeah, I can only say we don't know. There are some estimates saying it might be between 3.5 and 6-7 degrees of global warming, but that's really just estimates. And there's a whole lot of problems why we cannot really determine it. So basically, what we understand fairly well is the mechanism. Why does global warming lead to a weakening and potentially a shutdown of the overturning circulation? And this is related to this driver of the overturning circulation, that is the deep water formation in the subpolar North Atlantic. So there's places in the subpolar North Atlantic where the surface water masses sink to depth, and then we have the return flow. And the sinking process is basically, well, the way it works is that when the surface water cool down, they become denser and therefore heavier than the waters below and can sink. And density in the ocean water is determined by 2 facts, that is the temperature and the salinity. And now under global warming, what we're doing is we're diluting the surface waters in the subpolar North Atlantic, making them less saline by adding a lot of fresh water, which comes from the melting of the Greenland ice sheet. Also the melting of the Arctic sea ice, because even though sea ice is ocean water, it's less saline than the ocean water below, because the reason is kind of that this process of freezing the ocean water makes it less saline. And then also what we see, or what is predicted by many different climate models, is that we will have more precipitation over the subpolar North Atlantic, basically more rain, and rain is fresh water. So we have all these processes under global warming that make the surface waters less dense. And when we have less deep water formation, the AMOC will slow down. Or the slowdown is something that we're seeing already. And we don't know how much slowdown is okay before the AMOC tips. We, of course, can model that. But the thing is, climate models are pretty good at predicting trends and changes, but they're not that good at predicting like accurate numbers. The majority of the climate models say it's not going to happen until until the end of the 21st century. But that doesn't mean that that's necessarily true. And the problem is, for example, also that we know that climate models tend to have a little bit of a too stable overturning circulation, because they do not completely accurately model the salinity values in the Atlantic. And then often they do not include the Greenland ice sheet. And then, of course, they are missing one of the forcing factors that could weaken the overturning circulation. And therefore, yeah, we don't know. And this now just a few weeks ago, or I guess it's 1.5 weeks ago, this new study came out, which tried to determine how unstable basically, or how the AMOC already is. And they looked at the different proxy data of the AMOC for the last 150 years, and concluded that it looks like it already lost a lot of stability. The study didn't work on telling or estimating when exactly this breakdown will happen, but it's basically said, okay, it seems like we are definitely getting closer to it or approaching it. Yeah, I know it's frustrating, because basically I can only tell you we don't know. I guess what we do know, or at least I'm convinced of, is that it is a real danger of something that could happen. And if we do not stop global warming, at some point it will happen. But really how close we are, we don't know. And then the fact is also that, I mean, this is like a theoretical concept in the sense that once the AMOC, the overturning circulation, crossed its tipping point, it's going to shut down eventually, but it will still take a couple of decades just because basically the system, the ocean system is kind of slow in responding to changes or to changes in forcing. So tipping means only that we cannot stop it anymore once it's tipped, but it's still going to take some time before we actually reach this shutdown state.
So what's happening today, for example, in terms of temperature extremes, forest fires, droughts, are all things that were predicted, but they weren't predicted to happen quite this soon. And so again, a lot of it seems to go back to this magical 2-degree goal, which kind of ignored in some sense all the bad stuff that's going to happen before we get that far. And so I'm an economist. Our models are probably worse than yours, but this is I think, well, how scared should we be? From what I read, it sounds like the AMOS has collapsed at least once before that we know of. I'm not sure if that's true or not.
Okay, so basically, how scared should we be? I mean, that's a difficult question in the sense that you never want to be that scared that you cannot act anymore, but I would take it super seriously from my point of view. And yeah, so basically we have, as you said, we have evidence from paleoclimate data, so from the Earth climate history, that strongly suggests that the AMOC has had this shutdown states before. And we have a lot of climate models that are capable of showing that it can shut down. We understand the mechanism of why it would shut down and then remains in this shutdown state. And this is something that has first been shown in the 1960s from a simple 2D box model, or from a simple 2-box model, and then even in higher or more complicated climate models, we can see how this mechanism works. And you are right, I think, in the sense that when we talk, I guess, about communicating the knowledge about the Earth climate and climate change, we basically always give like our mean states or mean values. I mean, in the sense that climate models, they are different, and we have a lot of climate models, which is great, and they predict a range of responses of what might happen. And what is communicated is often the mean response. And we could be lucky and the response is less than this mean response, but we could also be unlucky and it's even worse than the mean of the climate models predicted. And as you said, this is something we, for example, see or have seen in the melting of the Arctic sea ice, which has happened much faster than the mean of the climate models predicted, and which we partly see in the amount of how the extreme events increased. So basically, there's no guarantee whatsoever if we stay below 2 degrees of warming that everything is fine. And we also know that even if we stop the carbon dioxide emissions tomorrow, climate change would continue for quite some time, because, for example, the ocean right now is taking up a lot of the carbon dioxide and a lot of the heat, this excess heat in the atmosphere. And if we stop forcing the atmosphere, then the ocean will start releasing some of this heat and this carbon dioxide. So we can't stop climate change right away, even if we stop our emissions or if we cut down our emissions. I don't know. I'm pretty afraid of what might happen, in the sense that climate change is affecting the whole globe. And of course, nobody ever said that everything that happens due to climate change is bad. I mean, some regions might just experience some nicer, warmer weather, but there are a lot of regions that will be affected badly. And then I think it's also the question of how fast are we able to adapt, right? I mean, in principle, for example, looking at our latitudes, I guess even with more heat extremes and so on, it will be temperatures that are where humans can basically live, but we might need more air conditioning. For example, right now I'm in Ireland and nobody here has air conditioning. You don't need it. But if we get temperatures that are largely different and we have more and more heat waves in the summertime, then we might need air conditioning. Or for example, the people in Texas, there everybody has air conditioning because they're used to heat. But I mean, this year in the winter time, they had the strong cold outburst with -degrees Celsius and so on. And that's what they're not adapted to and not adjusted to, which is why they had a breakdown of the power system. And that's the question, can we adapt fast enough? And because we are changing the climate really, really fast at the moment, and I'd say don't force it. And then of course, also the thing is, a lot of part that is climate change is it's stopping climate change, stopping global warming, goes along with protecting the environment. So I mean, just renewable energies are good for us in this sense. And I guess I just wonder, why not go that path if it comes with so many benefits? And even though we are not completely sure about what exactly we are facing. I guess, I mean, overall, I guess I'm not the most optimistic person. And I would say we have a huge problem with climate change, but I mean, we don't have a problem to the extent that we're all going to die. So we can do something about it. It's just that we really have to start doing it. And it's definitely true that the longer we wait before we do something, the more severe the consequences will be. And it will definitely lead to a lot of problems. But I guess, I mean, basically, what are the options? The options are we could give up and say, okay, we'll live our life like we do right now, and that's it. But I hope that's also not human nature. So we start trying to deal with it and start to try to solve one problem at a time. And right now, the main problem is stop emitting CO2. And of course, on a local scale, those cities that have already seen severe flooding and so on, they have to adapt to that and starting to do that and so on. But there is stuff we can do. We just have to start doing it, and we have to stop denying climate change is a problem. And maybe also we should really start to hold people more accountable. Those people that that basically knowingly deny global climate change as a problem, or that basically, I mean, in the sense that when you have companies that earn the money from coal or whatever, that they should be accountable for the problem that's going to cause in the future. So we definitely have to do that. I mean, so I'm really not an expert at that at all, but I mean, there are a lot of people that shown that we can, with a good carbon pricing scheme and so on, that this could actually work out for us all, in the sense that we are, I don't know, still can live an okay life and so on. I guess we do have to kind of think about making major changes in our lifestyle, in the sense that not everybody should or needs a car. And especially if we adapt our cities to more public transportation, then really not everybody needs a car. And we should probably kind of, I think one problem is also like really cheap flights. So flying shouldn't be that cheap, but if we do the right carbon pricing, then that should work out. But I guess we should get used to, you're not going to be able to do, I don't know, 4 long-term flights every year to whatever places. And yeah.
Okay, so you see some hope.
I do see some hope.
This is very
Sure.
interesting. I enjoyed it. So thank you.
You're very welcome. Well, then I hope you have a great day.
Thank you. You too.
Thanks. Bye-bye.
Bye.
Okay, bye.